I assume that you read the introduction here. So let's get right to it. Assume that an expression for the air pressure in the damaged tire is f of x is equal to 1 plus e to the power of 1 minus x, expressed in kilograms per square centimeter, where x measures the elapsed time in hours, not minutes or seconds. Remember, x is the time in hours from the moment the vehicle sets off towards the village. So calculate f prime of x and show that the function f is decreasing. Okay, of course we can just draw the graph of this function f of x and see that it's gonna go down, 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 down. But how to show this with the derivative? So let's just find the derivative. A calculator page, in menu, calculus, derivative, and the variable is x of the function, and the function was 1 plus e to the power of 1 minus x. Okay, that's the answer. So the derivative for all x values is this, minus and then e to the power of 1 minus x. One very important thing that we have to remember about the exponential function is e to the power of any value is always a positive number. Okay, so this part without the minus sign is always going to be positive. If this part is always positive and we have a minus sign in front of it, the whole thing will always be negative. Okay, so the derivative for any x value is always negative value, which means that f is decreasing. Okay, negative derivative means that the function is going down and decreasing. So we can just write the expression for the derivative of x, which would be this one. Okay, f prime of x is equal to this. Use the calculator to answer the following questions. Sketch the graph of the function f from x is equal to 0 to x is equal to 4. Let's get a a graph page. Once again, 1 plus e to the power of 1 minus x. What's the function, right? 1 plus e to the power of 1 minus x. It looks like this. So they want us to sketch the graph from x is equal to 0 to x is equal to 4. Okay, so from 0 to 4, that's this part. What is the air pressure in the damaged tire at the moment when the vehicle sets off towards the village? So this formula begins when time is 0, or x, which is the time variable, is 0. So let's just go back to this one, and remember, now we already defined the f1 function. It's this. Let's substitute x for 0. f1 of 0 is equal to e plus 1, that is more or less 3.7. So what is the air pressure in the damaged tire at the moment when the vehicle sets off? So the air pressure would be, we can round it off to 3.72, and then the unit would be kilograms per centimeter squared. What is the air pressure in the damaged tire 3/4 of an hour later? Okay, what should x be? Remember, x is the elapsed time in hours. So 45 minutes would be 0.75, since 1 would be 1 hour, but 45 minutes is going to be 0.75 hours. So let's just, instead of putting 0, we put 0.75. And now we have 2.28. So the air pressure after 45 minutes would be 2.28 kilograms per centimeter squared. The last question. The vehicle cannot proceed unless the air pressure in the damaged tire is greater than or equal to 1.5 kilograms per centimeter square. Under these conditions, can the travelers reach the village in their vehicle? And we have to justify the answer. So let's see. The village is situated 1 hour and 30 minutes away. So basically, let's put this into our formula. So 1.5 hours, because that's 1 hour and 30 minutes. 1.5. Let's substitute x 1.5. And let's have a look at the air pressure after 1.5 hours. The air pressure is 1.61. And it has to be greater than or equal to 1.5. So the air pressure is gonna, in the tire, is gonna keep going down, but it will only be, let's see, 1.61 after 1.5 hours. And as long as it is equal to or greater than 1.5, we are fine.